In this video, we're going to be looking at the skill on how to convert between compound units in a basic fashion. We're going to look at two examples and we will use proportions to help us solve. So make sure you have your calculator handy along with your composition notebook and pencil. In our first question, it says a cyclist rides her bike at a speed of 20 kilometers per hour. 20 kilometers per hour. I'm going to set that up to look like a rate. 20 kilometers per 1 hour. The question asks us, actually there are two questions, what is the speed in miles per hour? And then how many miles will the cyclist travel in 3 hours? In your computations, assume that 1 mile is equal to 1.6 kilometers, and we are not to round our answer. Okay, so a few things going on here. We have our original rate that is given, that she's biking at 20 kilometers per hour. We're going to address the first question while ignoring the second question for now. We're going to answer what is her speed in miles per hour. We're using the equivalent or the equivalency of 1 mile is equal to 1.6 kilometers. So our original rate, 20 kilometers per 1 hour, and we are trying to find out what is the speed in miles per hour. How many miles per 1 hour? This is not the proportion we're going to solve. This is just a way to set up your original information given to determine, okay, what is it that I'm actually trying to solve for? So what I'd like to step back and look at is here's her original speed, and they're asking, what is that same speed but in miles per hour? So here, our time units do not need to be converted. Their original information was per hour, and they're asking for an answer that's per hour as well. So that can be left alone. What does need to be converted is we need to convert 20 kilometers into a specific number of miles. Okay, so now that I understand what I'm actually trying to do, I'm going to solve using a proportion. I'm going to use this scale factor or this comparison that 1 mile is equal to 1.6 kilometers. Okay, that unit conversion, 1 mile is equal to 1.6 kilometers, is going to be half my proportion. And then my labels need to match. So the only other original piece of information they really gave us between miles and kilometers is 20 kilometers is how much distance she's traveling in an hour. So making our labels match, we're going to put the 20 kilometers in the denominator here. And we're going to solve for how many miles that is. This is your proportion, so we'll use our cross products. 1 times 20 is 20, and then divided by the 1.6 is 12.5 miles. So what is our speed in miles per hour? Our answer would be 12.5 miles per hour. And then we can address our follow-up question, which is how many miles will the cyclist travel in 3 hours? So she will travel at a speed of 12.5 miles per hour, and then in 3 hours, or multiply by 3, she will have traveled 37.5 miles in those 3 hours. Okay, let's try a second problem. Again, we're going to set up our original information to kind of get our bearings, understand what is being asked of us and how to solve, and then we'll actually set up a proportion to solve their original question. It says, as Saturn revolves around the sun, it travels at a speed of approximately 6 miles per second. 6 miles per 1 second. Convert this speed to kilometers per second. So original information given in 6 miles per second. They're asking us to determine how many kilometers per second is that. At this speed, how many meters will Saturn travel in 15 seconds is our follow-up question. Assuming your computations that 1 mile is equal to 1.6 kilometers, and we are not to round our answer. Okay, looking at our information, we're going from 6 miles per second to an unknown number of kilometers per second. Our increments of time have not changed, so we don't need to worry about anything there. We just need to convert 6 miles into our unknown number of kilometers. We're going to use this unit conversion, 1 mile over 1.6 kilometers. Again, you can set up your proportion however you wish, as long as your labels match. Miles to miles and kilometers to kilometers. So we have 6 miles in our original information will be over our unknown number of kilometers. And then you'll use your cross products from there. So 6 times 1.6, and then that divided by 100, or excuse me, that divided by 1 is still itself 9.6 kilometers. So our first question says, we have to convert our speed into kilometers per second. So this is our answer to our original problem. There is 9.6 kilometers per second. That's your speed. Then it says, how many kilometers will Saturn turn in 15 seconds? So 9.6 kilometers in 1 second. So we'll take that times 15, and that will tell us how far it will have traveled in 15 seconds, which is 9.6 times 15 is 144 kilometers. So a couple helpful tips on this problem, again, is to set up your original information to kind of figure out, what am I converting? Am I converting time? Am I converting distance, money? What am I doing? And then secondly is look for that scale factor. That'll help you set up your proportion, 1/2 of your proportion. And finally, I'd ignore the second question, the follow-up question, until you've actually solved the first question. Don't let too much information overwhelm you all at once. I hope going through these 2 examples have helped. Make sure that you've got good notes to use as you practice, and if you have any additional questions, please ask your teacher.